other screen. Wonderful. Okay, that is ongoing. Then I'll share my screen. And we have a couple of housekeeping-esque things to do, and then we'll get into today's session. Screen 1 or screen 2, which do I feel? I think screen 1 is the correct one. Okie dokie. So, in a second you should see a Fusion window, probably. And from there, so you're presenting to everyone. Thanks for letting me know, Windows. I'm aware. Alright. Cool. So, I guess, we'll start with the classic. So in the Discord, I'll go ahead and ask, in a lovely little poll, how is everyone doing today? I get the vibe that the end of the semester is sometimes a bit, meh-worthy, but I believe in you all. You can power through. I've made it this far, and I don't quite know how, but I'm sure you all will be able to do the same. Alright. Nice, okay. Some good responses. A meh response. I myself might be floating around the meh. I feel like I'm doing well today, but also it's been a very busy week, so. Alright. So, next housekeeping thing. Continuing with the theme of pretending to be more organized, I think I'll send out the little attendancy form thing. It should be the same one as last week. Either you'll be able to fill it out a second time, and it will be fine, or you won't be able to, and it won't be excellent. And I'll fix that later. But if you could at some point, just go ahead and fill that in. Just put down your name or whatever, so I know that you were here for the session, so we can keep record of it or whatever. Awesome. And then also, we'll take a quick look at the survey thing that I put out. So, there, not actually sure if that's quite large enough. I'll make it slightly larger, just so people can see. So, when I asked for next week what people want to do, we got some mixed responses. Unfortunately, because of the nature of Google Forms, it's somewhat slightly difficult to make decisions in cases like this. The largest chunk of people voted for a new topic. However, I feel like blue and green kind of go well together, seeing as they're a bit reviewy, a bit challenging. I was thinking of doing some mix of the three, so I'll propose this, and then I'll get a little Discord poll, and you can give me a yes, no, or meh. I was thinking for our next session, what I'll try and do is put together a little challenge for each of the, units or topic things that we've covered, and I'll just give a big list of those before, or, at the beginning of the session. So if people want, they can pick something and kind of run off on it. And then what I can do is, throughout the session, go over these bits. So I'll have, somebody will say, I'm working on blah blah blah, and then I'll do, okay, I'll help you get started, and then on the whole call for everyone to see, I can work through maybe the first part of the challenge or something like that. So that way it's a bit of review as well, because I won't just be setting you off on your own. And then I was thinking I could maybe toss in some of the challenge problems could have some new topic linked. And maybe I could find a way to discuss that as well. But I don't know. So I'll ask in the Discord, in the poll, what do people think about a session with practice, exercises, and some review with a sprinkle of novelty. Novelty being the new subjects. Yeah, I guess just let me know what you think about that idea for next week. And then our last week, it will probably be the showcase thing. People rather universally and understandably said, meh or no, I don't want to show off something of my own, which is entirely understandable. But also, universally, everyone's interested in seeing what the other teams have to show off. So it sounds like ARM is definitely, I think, going to have some things to show off. Hopefully Lig as well. And I think BCI might have some things as well. So we will certainly see. But yes, there should be a nice session. That's going to be week 10. Should be very laid back. I think you'd have to ask the socials officer, but I think very soon after that big like showcase session, we'll also have a social, I believe. So that'll be a nice relaxing week 10. And then maybe next week will be focused on like revision-y things, but with some challenge, so it's a bit interactive and some new stuff so nobody gets bored. Excellent. Okay. Well, I've got 4 people who've given that a thumbs up, so that is pretty alright. Hopefully that doesn't irk too many people. So I will work on that, and then hopefully next week I'll have something exciting to show you. Wonderful. Alright, so I think that's the extent of the housekeeping-y things that I had in mind for today. And then I guess we'll just be able to get on with the session. So today's session, I'm thinking, is going to be focused primarily on, well, for the first half, advanced fusion techniques. So, yep, there we are. There's my list of things I wrote down to go over. So we'll start with advanced fusion-y techniques, and then we'll eventually work our way into how you might prepare a piece in Fusion for 3D printing or laser cutting. So, unfortunately, it's a bit logistically complicated to get a bunch of people into the iForge at the moment. We'll probably try and definitely do that the second semester, if you haven't already been. The iForge is a really nice workshop where you can build a number of different things. Very nice things that they have there are 3D printers and laser cutters, and so you'll probably be building lots with those when you're not just working with the hand tools and things. So we'll go over how you can take some of your models that you make and prepare them for those processes today. Alright, I think how we'll probably start is with another one of those practice problems. So I sent them out all last week. We'll try and hunt down the right folder. So if I go ahead and open and go to my desktop and find Fusion 360, which is certainly somewhere. There we are. And it's one of those exercise documents. Turns out it's this one, maybe. Okay, I didn't know, or I didn't really want that open in Adobe, but that's fine. And then we can go down to a new part that we have not seen before. So there's this advanced part here. I have made this one. I probably won't have us make this one today. It's something I think that, well, with the skills that we learned last week and things we'll pick up on today, you'll probably be able to pull this off, and of course you can always ask for help. And I think this one still has a solution, so you can actually download the solution file from the linked exercise solutions, and you can go through the Fusion timeline and see how it was built. For us today, I think we're actually going to build this part, which is rather different, I guess, because it's a bit curvy. So it's worth a look. Now, I think when I built this, it was less than perfect out of the gate, but we will certainly figure it out, I reckon. And we can get pretty close, I think. So, I will go ahead and relegate that to the side. That takes up so much space there. There we are. I think that makes it go away. Wonderful. And it gives us actually a bit more information. So, can everyone see this all right, by the way? I assume it's okay. Wonderful. Awesome. And then hopefully Fusion is big enough. It's the same size as last week, I believe. Alright, so we'll go ahead and toss Fusion over there. Toss you over here. Maybe zoom that out ever so slightly. And squish it over a bit more. That was not what I wanted, Adobe. Okay. So, I think what we're first thing to do is figure out what this shape kind of looks like in our head a little bit. So it's this oval structure for the most part. We have the size of the major and minor axes, I believe. And so the major and minor axes of an ellipse are just like the major one is the long diameter and the minor is the short diameter. So here, this 152, that is our major axis. And then our 75 here is this minor axis, so that's down the middle there. So I think what we should probably do is start with a sketch that shows that. So, if we're starting with a sketch, we can go for Create Sketch up here in the top left. Go ahead and place that on the ground plane probably this time. And then it's down to drawing an ellipse. So, does anyone off the top of their head remember the keyboard shortcut to bring up that little toolbox that we can search for things in? It's a nice, really helpful toolbox shortcut. I put those words together. Anyone remember the key for that? S, yes, wonderful. I would agree. So we can go ahead and press S. We can search for ellipse. There we are. We have an ellipse. And then here, we have to do three things. First thing we do is place down the center point, so I'll put that in the middle. Then we give it, I believe, the major axis. So this one's going to be 152. And place that. And then we drag it out. And this one is going to be 75. So that is the outside of our ellipse shape here. So that's our primary thing that we're looking for right off the bat. Next thing we can do is think about how we might design this inner ellipse before we get a bit too fancy here. So let's see, do we have any more information over this side? Yeah, a little bit here. So wonderful. Here you can see this is detail B at 2x scale. So detail B, if we take a look and we're looking for detail B, that is this section here. Additionally, last week it was pointed out to me, I think it was by Isaac, that my mouse sometimes does not actually scroll over the things that I'm pointing at. Can you see my mouse on the screen, and is it around the design bit on the left? Or is my mouse just randomly vibing about? Dun, dun, dun. So I guess I'm circling the bit on the left. Is that a no, people can't see it? This is in the PDF window. Cool. Okie dokie. I'll try and be very good about my descriptions. I can't see it, got it. Excellent! Alright. Very exciting. In that case, I will try and describe things very well verbally. I think it shows up on the recording for the people watching on the recording. I checked that. But for some reason, Google does not seem super keen on sharing my mouse in the correct spot. So, instead, sorry, I will try and describe things very well. So here is this window on the left, the exercises.pdf, where you've got the design. You see your big ellipse shape, and then up to the top left corner of this ellipse, you have a little circle that's labeled B. It has a little B here, and it's circling a hole in the design. If you go and slide over in this document to the right, you see that's detail B. So this is like a zoomed in portion. I'm now looking at the part that says detail B. That's a zoomed in portion of the bit over here that's circled in the top left of this ellipse. Wonderful. And sorry about that mouse issue. I'm not entirely sure what's causing that. But we will do our best. Okay. So, the key bit of information here in detail B is these offsets, or are these offsets. So it tells us that the middle point of this hole is 6 millimeters from this outer edge, and that the kind of like pocket inside is offset 12 millimeters from this inner edge. So, first thing I'm going to do is probably just make this big overall ellipse shape. So what we can do, if we want to offset something, we could make a second ellipse and do the maths ourselves to calculate what the major and minor axes should be. But there's a much, much easier way to do that in Fusion. I think we encountered it maybe last week. If not, we're encountering it now. So surprise! This offset tool here. So it's up here in Tools, it's right next to Trim, which is a little cut thing that we found before. Offset. You can also press the O key on your keyboard, I think. Whoops, you gotta be clicked on Fusion. Yeah, the O key on your keyboard. Then you can click on the curve that you would like to offset. So I'd like to offset this thing here. And then you can say, well, I'd like it to be negative 12 millimeters in or whatever. However many in you want it to be. In this case, yes, I do want negative 12. So I can type directly negative 12 and then enter. Wonderful. Alright, so there. It looks a bit squirrely, if I'm being honest with you, but I think that is correct. Yeah, I suppose so. Maybe it just looks a bit odd because it's zoomed in a bit. Yeah, okay. So we have that. we have our major axis 152, that one was 75, yep, and it's offset inwards. Okay, that seems reasonable. Now what we can do is we can also offset this other one. So note here, and they kind of try and show it in this diagram, it's a bit of like a dotted line, sort of, maybe a lighter line, hard to see. But you can tell in the final version of the part, which is up here, there's not actually anything cut through the middle. It's just a place that all of these little holes are sat on top of. So in our case, what that's really going to be is a construction line. So we can repeat our exact same process. We can do O for offset. I'm just going to click on Fusion. O for offset, click on the outside, do -6. So that's setting it in by 6. And then create. Now here, you see we get these two faces. That's not really what we want. What we want is for this middle one to be construction line. So we can click on it once. And we can either press this button here, which is this construction line in the top in the sketch palette. It looks like a little angle with some stuff between it. Or you can press the X button. So if I press the X button, you can see it turns into this dotted line. If I press X again, it transfers it back into a solid one. So you can move it between construction and not construction there. And you can see up where this construction line is, in the sketch palette, the construction button rather, it's flipping from toggled to untoggled, so blue to not. So we'll keep that a construction line for the immediate moment. So that is looking pretty good so far. The next thing we should do is probably add the cutout for this circle here. So that's a detail A. So if we're looking back on the PDF side again, where we have our design, to the right side of this upper part of the design, there is this hole. That hole is described further here, detail A, also up here in the middle. And that shows this circle, and it's got this little notch cut out at the very top of it. It tells us the inner diameter of that is 20. We still don't know the outer diameter of that, which is what we would like to know at the moment. And so we can look down here, and this cross-section area is actually telling us that it is 35 across. So we know that this little cutout, or the bit that this is going to be raised up, rather, the detail A, that is a diameter of 35. And that circle starts, we also know here, if you look at the middle axis of the elliptical shape, kind of, you have this measurement of 40. So what's 40 millimeters away horizontally? That would be the center of the circle. So I'll pop up my circle tool by pressing C for circle, clicking on Fusion first, and then I'll just place it somewhere arbitrary. I'll make it 35 in diameter, because that's what we're going for. And then I can pop out my dimensioning tool by pressing the D button. So press D, and I can press the center of the circle, and then the center of the ellipse, which is just the origin, and those are 40 millimeters apart. Well, that is not entirely what I was going for, was it? Okay. So what it's done there, actually, is move this construction line, which is a bit interesting, given that construction line should have been offset from the outside, but it looks like somewhere that constraint was lost. So we can reassign that constraint. If we go down in our constraint menu, I think we can reassign that anyways. Maybe not. In which case, yeah, okay, what if we try our sketch dimension thing in between the two? Nope, doesn't really like it. Fascinating. Got it. We'll try remaking that one, because that's rather strange, that it lost that offset constraint. So we'll press O for offset again, click on this here, offset it by -6, so that's what we're going for, enter. Yeah, so it's not really left as a constraint there, so it's an unconstrained circle, which is slightly frustrating. We could try offsetting from the center one, see if that makes any difference. One or more of the curves has already been offset. Okay, cool, so you have to select the new one, which is kind of what I assumed. Exciting. So, I'm not entirely sure how we'll tackle that just yet, but we'll figure something out. Because I've done this before and it hasn't given me this issue, but oh well. Okay, so that one, we'll make it a construction line again. I guess for the time being, because that can move actually entirely freely, that is entirely unconstrained. If I search offset, Yeah, it is really not too happy about that, is it? I'm not sure how to best address that. It's just a bit of a frustrating situation, isn't it? Okay. Well, for the time being, then, what we can do, I guess, is get a little bit cheaty with it. Because this middle one is definitely constrained by that amount. Fascinating, isn't it? Okay, maybe if we try creating them in a separate order real quick. I'm dubious that this will work, but we'll give it a go. So here on the very outside, offset first by -6. Nope, not constrained at all. And if I try offsetting again by -12, now it's also not offset. Huh, okay. So maybe this is just Fusion being a bit persnickety with us. To solve this one, maybe if we, any idea, had to redo it a couple times, might have to do with pressing enter too quickly. Well, fascinating. It's very good that you're keeping an eye out on that. So let's try instead just doing it a bit slowly. So there we are, and pressing enter. Now that time it went entirely away. Now I think that might have been my fault, to be fair. Okay, well, maybe we'll just have to lock this one in place and not offset it properly, which I don't really want to do I? Okay, yeah, not ideal, is it? Any information down there? No, just a flip thing. Chain selection, maybe if I turn that off. Okay. Yeah, okay. So, Philip, you just did exactly what I've done and it's worked for you somehow? Is that the general idea? Wild, okay. Yeah, I think I might have to leave that one then. Yeah, problems creating constraints there. Fascinating. Well, oops. I was trying to check for a solution on that form, and I don't think we'll have much help here, will we? Yeah, okay. Got it. Well, for the time being then, I guess we'll treat that as a construction line, and we'll try and constrain that just into place. So we can do something like a, well, we can constrain the size. So if we grab our dimensioning tool, and we click on the ellipse, we can do a couple of things. We can give the minor axis what it already is, so just click there, click enter. To constrain the major axis, we'll do the same, but go this other way, enter. So now the size is fixed, and then I guess we'll just make a coincident constraint with the center of that ellipse and the origin, which is also there. Yeah, there we are. And now it's, I think, fully constrained. Not quite. The rotation is not quite there. And then we can say, if we take a bit of it, maybe, and, ooh, can we create another construction line across? Let's see. So construction line there, and there. Well, that's a bit hard to see, isn't it? Yeah, okay, that's gotten very difficult to see. Well, we're nearly there. How should we constrain that? We can just lock that into place, I reckon. So we'll go ahead and fix that. Now is that done and fixed? Okay. So now that's locked in place. That's very, very strange, especially seeing as it worked for Philip, and it definitely worked for me the first time. I'll have to get back to you at some point on why that is. I don't fully understand the reasoning. Try and press O. How do you mean? Then click on the ellipse border. Ellipse border. So you mean this middle bit. Alright. So at the very outside, pressing O, clicking on the ellipse border, then we're here. Because I think this is where I've been before, and I've gone and done a -6. And, and then enter. Yeah, doesn't seem to like that a bunch. Oh well. Yeah, we'll just go ahead and fix that in place, and I think that should do it in one. Alright, well, that's a bit odd. If it works for you, excellent. If that didn't work for you, I'll try and get back to you on why that is at some point soon. In the meantime, we can continue on with the shape. I've just fixed it in place for now, so I think it should be, fixed so it can't move. This fixed constraint just locks something at its exact current state. The size and location of the object. Usually, you should avoid using that, but in this case, I'm going to have to use that because it's giving me some trouble. Excellent. And, okay. Cool, my chat just went away. That's fine. So, we'll move on then. From that bit of a struggle there. I can take my dimension constraint, which is D, here, and go from the center of the circle. Oh, of course I have. Right, for people in the recording, I've just been booted from the live session, so we are waiting for my network to reconnect, apparently, which I'm not terribly optimistic about. Maybe I'll refresh the thing. Hello, that was traumatic. Can you all see and hear me still? Wonderful. My internet decided that today was not my day. My computer in general seems to be in a very bad mood, as Fusion has also decided to stop responding. But that's fine, because we will power onwards. Just to double check, can everyone currently hear me at the moment and see my screen in just a second? Okay, you can hear me at least. That's good. I can at least annoy you all. Sorry for that. Alright, and as I'm sure you can see if you can see my screen, Fusion has stopped responding. So I guess we're going to close that and technically lose that progress that we've made there, which is not ideal. Go on, close. But what I think I'll do, since that's giving me so much grief, is go through and show you how I created it in the model that I did ahead of time. Right, and just to double check, you can see my screen again, right? Okay, excellent. Wonderful. Hello, Nick, if you just joined. You just missed my internet dying and my Fusion crashing and us losing all the progress in the sketch we were struggling to do because Fusion decided to break.
I'm joining while walking home.
Oh, very exciting. Right, well, we're hoping that Fusion is actually going to launch again for me. It is not responding still, even after a relaunch, which is very exciting, given that this session's content is entirely to do with Fusion 360. Okay, we will try purging it with our friendly task manager. Bye-bye, Fusion. No more fusing for you. Maybe. Goodness, I can't even find it. Nope, no luck. Fusion launcher, that's the one. Go away. Who needs you? Okay. And that has not done anything for us, has it? Oh, there we are. It's thinking. It's spinning up. Maybe. Hey, look at that. Okay. Open. Sure, why not? Okay, cool. Right. We are back in partial action. We have at least what we were in the middle of creating still. That is good to know. Thanks, Fusion, for recovering that at the very least. We'll go ahead and click on the sketch, so we're back into editing it. And here we are, before the debacle. Alright, I'm assuming everything's good. You can see the sketch. It's functioning. Screen share. You can hear me. All is well. I'm very paranoid now. But, excellent. Fantastic. Thank you. Philip Maria, calming my soul. Okay. Sorry for the trouble. We'll continue then onwards with what we were up to. I think what we will try now is to constrain this circle to be a correct distance from the center here, which we decided from looking at our design. If we take a look at this number that is above the 152, you have this 40 millimeters, and that 40 millimeters is the distance from the center over to the center of this little hole cut out. So what we can do is press D to get our dimensioning constraint up, and then click on the center of the circle and then the center of the ellipse, and bring that down, and we'll type in 40 millimeters as the distance between the two. So you can see there we are. We have this rather interesting looking shape coming together here. Now, the next thing we need to do, or at least the next thing that I'm thinking off the top of my head we could do, is build this weird wiggly shape that's near the center. So you see where we have this design, so we're looking back on the left on the PDF again. Outside of the circled A area, you also have this kind of curve. It curves inwards at the middle, but then it kind of curves outwards next to that. It's this bit of a wavy shape, but we're given a little bit of information which we can use that's helpful, and that is that this middle arc here has a radius of 25, or sorry, 25, and at 25, I am assuming, is here from the center of this circle. That's an assumption that I've just kind of had to make, but usually you'll be able to tell decently, obviously, when you've made a wrong assumption, at least like that. And then these here are other arcs of radius 14.5 on either side. There's a couple of ways that we can go about doing this. I think the first thing I will do is make an arc with a radius of 25. So I will go on, click back on Fusion. Fusion will probably get upset at me, so I'll press Escape to move out of that tool. Then here, I can press my S key to pop up our toolbox, and I'm going to search arc. There's a number of different arcs we have available to us. I think, in this case, I'm going to do a center point arc, because I know where I want the center to be, and I know where I want the end points to be. So with the center point, I'm going to click on this center, which is the circle here. That's kind of what I'm assuming is correct. I'm going to click on one side, and I'm going to go over and click on the other side. Sort of. Not sure if that'll constrain. Partially constrained, so that's not fully constrained there. So you see how there's this dot here still in the end. So for some reason it didn't want to snap to this other edge, but we can make it. So we can grab this coincident constraint up here, which is the two lines coming together at a point. We can click on the curve and then click on the arc. Then you see the little dot goes away. We're back to something fully touching both ends. Then what we can do is grab the D, maybe not. We can grab the dimensioning constraint tool by pressing D, and click on the arc, and then you can see it gives us a radius measurement. So here we can just make that radius what we were told, which is 25. Just like that. Now you'll notice you have these weird bits kind of at the corners where it does more of a wiggle kind of shape. Well, that's very scientific, I know. But it curves back the other way, so you don't have like these sharp cusps around like this area here where this edge meets this one. There are a couple of ways that I think we can do this. I think that we'll go ahead and take a look at one. We'll try a way that I haven't done before, just to toss some extra excitement into all of this. So I'll go ahead and grab my arc again, center point arc. I'll click on the center. I guess we can assume that that's that one. And then, yeah, so I think that is too far, which is understandable. You know what it's probably from? It's probably from this intersection point here. That makes much more sense. So the other way, by the way, to do this, which is the way that I've done it before, is you can add a fillet between the two. So you can add one there and then this, but you have to cut this line first, which is why it's not ideal. But I think here what we'll do is we'll pop up our sketch toolbox with S. Then we'll go ahead, search for our arc again, grab our center point arc. This time our center point is this intersection here. Then we're going out, and we're going to click on one side and onto the other side, and we take our dimension constraint. And it's going the other way, isn't it? Yes, I see. Right, okay, so a number of different approaches. Yeah, so it doesn't immediately tell us what the center is. So it's just kind of assuming that we're sticking it in there. Another way we could go about this, actually, is creating a circle, I reckon. So if we create a circle, we just double this the radius they give us, so we can get a diameter. So they give us 14.5 as a radius. So if we double that, we should get 29 as our diameter. Then what we can do is get this in just about the right place there, and then we can do some constraints, just stick them together. And I think, actually, I'm not sure if it will let us get away with this if we do a tangent and two circles. Yeah, I don't think so. Okay, yeah, I think what I'll do is go about the fillet method of doing things, because that's what I was doing before. Yeah. Yeah, I think that's probably the way to go about it. Okay, so I'll show you that one. So if I go ahead and get rid of that circle there, we can come around here, and this line, or actually we can bring out our X tool, which is X, and that won't let us quite split the whole thing. Or even we can add it after an extrusion. So I think what we'll do is go ahead and extrude things. Sorry, this has been a very experimental part, this. So we'll go ahead and click on these. All of these, we want to bring them up. So I'll click, yeah, so we're on extrude. And we want to bring this up by 10, because we're given this thickness over here in the PDF. It's 10 millimeters. So we'll go up 10 millimeters. Go ahead there. Of course, it's decided to not fully extrude that, because this part is slightly cursed. That's fine. We'll go back, click on that, bring that up 10 millimeters. Are you happy about that? Sure. Okay. So for some reason or another, it doesn't want to let us do it all at once. That's fine. This one we can actually bring up 20 millimeters, because this section over here shows that it's another 10 above the face, so we can come up that way. We can then turn off our sketch and come in and finally make those fillets to fix this part of the shape. So this is the way I did it the first time. I was trying to do it a different way this time. Probably should not have been, but that's fine. So we'll go ahead and pop up our toolbox with S, fillet, and this time we want to go to the one that's not a sketch fillet. That's what this is. You can tell because it's displayed by a line. You want to go to the one that's there for bodies or parts. So we'll go ahead and click on that. Click on both these edges that we want to apply the fillet to, and then our radius is 14.5. So we go ahead and do that. Now that is much better looking. It's probably what we should have had from the very, very get-go, but I was deciding to get a bit experimental with things. So there we are. So that's our overall shape of the base bit. So now we have a couple of other things left to do still. We have this circle bit to design up here, so I reckon we do that next. That's nice and easy, relatively speaking. So we can right-click on any surface, remember, to create a new sketch. So I'll right-click, click Sketch. Then we want a circle with a diameter of 20, so I press C to get my circle tool up. Wait until it snaps there to that center point. Click there, and diameter of 20. Wonderful. And then on the very top, we have this little notch, this kind of cutout thing. And it gives us a couple of dimensions there. So we'll go up here. There's a couple of ways to build this one. I think I'll build this one with the line tool, just to show that off. So L brings up the line tool. So it's the L key. That's also this. It's highlighted up here in the toolbar. I'll just sketch a very, very rough kind of notch on top, which is not correct. But it's added some constraints at least, so it says that one's vertical and these are perpendicular and they're coincident. Now what we can do as well is make this, or center this rather. So if you think about it, we have two lines here and we also have a center point, so I think we can use a symmetry constraint in this case. So if I press my toolbox, bring up my symmetry constraint, I can click one edge, the other edge, and then the center, which is this point. No, it doesn't like that very much. That's fine. Meantime, we can add some other constraints. So we'll add the height one. So the height in this case can be 2.5. And the width is going to be 4, because that's what we were given. Alright, wonderful. Now, all we need to do, you can see it's still blue, because it can kind of go around like this. So we want to constrain this so that it is centered. There are probably a few different ways to do that. I think in this case I'll be a wee bit lazy, and I think it works just fine. And we can take our dimension constraint, so press D. Oops, I need to unclick off everything. Press D, and grab this left side here, grab this center point here, and say that that is 2 millimeters away, because that is half the width. So we go ahead and get that. Now you can see it's black, fully constrained. If I grab my cutting tool, oh, have I been pressing the wrong thing for the trim tool the whole time? Yes, of course I have. So that's why it's probably not been working for me. Probably would have worked earlier. That's fine. T for trim, not X. I was thinking cut and paste or something. So T for trim. Go ahead and grab that. Then you can cut this little red segment here. You have a nice hole, or notch now in our circle. It gives us a little warning. That's fine though, because everything is still blue, fully constrained. Now what we can do, press Q to get our push-pull, press on this face, and we want to cut all the way through the object. So remember, when we do that, we want to grab our extent and to object, and then click on the opposite face. And it goes slice all the way through. Okay, chop chop, and cut on through. Wonderful. So now, if you take a look at it, we are most of the way there. The only thing we have left to do, actually, is make these holes. Now, the holes are a bit sneaky in this particular design. You can see here that it says at the very top, all holes, this is underneath exercise 1 or whatever, where there's text. All holes are countersunk for an M3 flathead machine screw, and all units are in millimeters. Now, I won't lie to you, I didn't know how an M3 flathead machine screw was designed, and it turns out there are different types and shapes, so they made a bit of an assumption here. The M3, however, does mean that the central diameter, like the width of it, of the bolt that goes into it, or the screw, is 3 millimeters, so we know that much at least. Countersunk means that you have like a bit of a funnel shape at the top, so the head of the screw also goes into the hole. I'll show you what that looks like in just a moment. I'll probably have to guess a little bit on the exact values of that countersinking. I figured it out before, but that was only by looking at their example, because I think it's slightly ambiguous. But first thing we will do is add that hole. So that actually introduces us to today's first new tool, which is the hole tool in Fusion. So under Create, or actually here at the very top, you can see there's this hole option. You can also see it's bound to the shortcut key H, and this creates a hole based on user-specified values and selections. So I think what we will do here, so we know where to put it, we'll bring back our sketch from the bottom, and here you see that we had that construction line there. Actually, hey, let's get really brave. Let's try and do it on the top surface and a bit differently. So if I right-click here, on the top, create a sketch, and I press O for offset, and I grab the outside, and I bring it in by 6, hit enter. Is it happy? Look at that! Now the constraint works. How absolutely magically arbitrary. Wonderful. We'll turn that into construction line by pressing X. Now we have our dotted line here on the top surface. Then what we'll do is add a placeholder kind of for our hole. So instead of making these in a sketch and then extruding them through to build our holes like we did with this hole, we're going to be using the hole tool. But it does sometimes like to have a starting position. It makes it a bit easier to place, I guess, for you, the intrepid designer. So I'll go ahead, click on my circle tool. You could also just click C for that. And you can see it snaps now to our construction line. So that's the midpoint of this thickness here. I will go ahead and click there, and I'll make this hole 3 millimeters, because that is the size of at least the inside of these holes. Now you can see this is unconstrained. That's because it can go wee all the way around. We want it to be in a particular place. Let's start it, because we know there's one hole, or actually 2 holes here, directly on this vertical axis. So looking back at the design, in this upper design, you can see there's a hole, and it's getting, or it's right down the middle. So I will align that. So I'll slide this slightly over so you can actually see what happens here. And so we have the origin there, that's fine. I'll go ahead and grab my horizontal vertical constraint, and I can make the center of that circle vertical with the center of this one, which it did not do. Alright, okay, if we pop up the origin, are you fine with that then? No, okay, maybe we need to zoom in a bit if we're missing these center circles. Got it, okay, so that's still sliding about. I would like to make that point, please, vertical with that point there. There we are. Okay, Fusion is really fighting me tooth and nail today. Regardless, eventually we got there. You can see it's black now, it's fully constrained, can't slide that hole around anymore. Or that, rather, outline for a hole. So in fact, we'll make that a construction line, because we don't plan on actually cutting that out. We can finish this sketch and use this as a blueprint now for our hole tool. So to get to our hole tool, we can press H, or you can press the hole option up there. Excellent. It says placement. You have a couple of options, so at a point or from a sketch. So I'll say from a sketch, select a sketch point, and I'll click on there. Now you can see right off the bat, that's a massive hole, probably not what we're going for. So remember, an M3 screw means it's 3 millimeters in diameter, so we can put in 3. And then we have, ooh, intriguing. So, okay, so it's actually editing the wrong thing at the moment. So here you can see on this menu a bunch of different parameters. So one of which is the depth of the hole, which in this case I'm actually going to switch back from distance to 2, and then from there go ahead and click the bottom so we know it goes all the way through the object. That's what we would like. Now we can go and change this diameter of the hole. Diameter of the hole should be 3 millimeters. So you can see that there has shrunk down the hole quite significantly. But now is the bit for this countersunk detail, which they gave us over here. It's a countersunk for an M3 flathead machine screw. So we can go over to these hole types, and we have simple, which is the one we have now. That's just a cylindrical cutout. You can also change like the threading of the hole. So tapped means it's got threads. Clearance means there's a bit of room around the inner diameter. And you can also have a pointed or flat bottom, but ours is going all the way through, so it doesn't actually matter in our case. Although, yeah, so flat slightly simplifies this view at least. But what we want to do now is click on countersink. So you can see, maybe based on this symbol here, it's very small. You'll be able to see it better in a second. It's a bit of like a triangular shape at top. So if I recall correctly, it's a 90-degree countersink. Yep, just like that. And the head was maybe 4.5. Yeah, it might be about right. Maybe it was 4.75. Something along those lines. And then we can go ahead and actually click OK to cut out that hole. So and then we can look at it. So when you see now the countersinking, it's like it's a wider hole at the very top, and it narrows in to that 3 millimeter diameter for the actual hole. And that goes through there, kind of funnels in. So that's what we're looking for. So there's one of our holes perfectly done. But now we need to duplicate that, well, how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more times. So we can go ahead and give that a go. But how can we duplicate it around on that elliptical path? Well, there's a tool for that. So that's another one of our new things we get to see today. So we'll actually go ahead and bring back my last sketch that I did here, which was this nice ellipse outline. And we can encounter a new tool. So I will click S to bring up our searching toolbox, and I will search pattern. And you see we have a number of different patterns that we can create here. We can create circular patterns, which I think we actually saw in our last go around. Rectangular patterns, which are new, but I'll show those off eventually here. And then we also have pattern along path, which puts something around this path. And in this case, we have a path that we want to put things on, so we're going to use that one. So let's do pattern along path. When you're selecting the thing that you would like to make a pattern, remember if you want to select like some part of an object, I guess they call them features. I think that's the best name. So if we want to put this hole that we made on a pattern, we can click features over here. The feature that we would like to put on the path is this hole. So I can go down here and click on this hole. So we have that feature selected, and we can see now it wants a path. So we click path, click on our elliptical path. And now you can see we have some options for duplicating it all about. So there's how we can put one around. So I think what I want to do here is, yeah, extend is fine. So I'll go all the way around with my thing back to here, so it locks back on top. This little hole, and I can go ahead, because that's all the way around, so that's the 360 degrees, and I can just increase this quantity. And you can see very, very, very lightly, it's like frustratingly light at the moment, that more of these holes are appearing. Actually very, very difficult to see at the moment, aren't they? In fact, you can hardly see those at all. Okay, if I go ahead and click OK, what does it do for me? Right, okay, so at least, yeah, so there it makes the holes more visible. So you see there that I've done 7 holes. We actually want more than that, because this is not quite enough. We want actually just about double that amount. So if I go back into the path pattern, remember you can double click on these features to edit them, and I can go ahead and increase the quantity some until it gives me something a bit more helpful. I'll do one more. I think that's right. 11 overall, that's what we counted earlier. And then OK, and there we are. That's better. Not quite. Just kidding, more still. Okay, so go ahead, quantity, tick up a couple more. There we are. Now we can actually see all of them. Yeah, all these little check marks. Perfect. And then OK. Right. There we are. Now we have our evenly spaced holes all along this perimeter here, and the correct number of them, which is what we were going for. So that, I believe, is our final part. Now, whether or not this will closely match up with the weight that we've been given, I'm not sure, because I think I made these countersunk holes slightly differently. These curves maybe a bit as well. Oopsie. But we can certainly give it a go. So, to apply physical property, remember that you can search just for that option. So, physical material with our S menu. I believe they had us testing with metal, aluminum 6061, which is here. Click clock. Alright. There's our physical material. Then we can whip out our density. So we go under bodies, right click on it, give the properties, and we can see the mass of this is 160 grams. So hopefully this isn't terribly off. I don't think this will be spot on because we did make some guesses here. So hop in here, exercise answers, and yeah, so I think this one is exercise 7, in which case they got 158.8 grams, so ours is just slightly heavier. Which is probably a product of either those inner curves or the hole cutouts, but there's a bit of ambiguity there. Supposedly, this is loading the answer, but it's not actually doing so for me. So maybe you have to see if you have some better luck loading that answer from that answer file. But from a visual inspection, at least, which might be the best we can do in this slightly cursed session, is just take a look and see that this seems to match our design rather well. Okay, go away. So we have our general ellipse shape. We have this oddly shaped cutout here in the middle with our arcs at the proper radii, and then this notched cutout there. From the side, that notched cutout is raised 10 above the rest of the part. Holes in the middle, they're all evenly spaced. So I think that is decently well, or that's the design we're going for. The one that I prepared earlier I think is very, very similar. Jump into Bionics Bootcamp, exercise 6. It's 6, not 7. Oh, but I also didn't number these totally correctly, did I? And the first time when I made this, and this one I checked was decently correct, we can go and get the weight of this one under properties. Yeah, exactly the same, 160. So we've done the same thing both times, which is good. Alright. I'll pause here and ask if people have any questions, because we have done quite a bit, to be fair. We've also struggled quite a bit, so I would totally understand if I've lost anyone along the way. So I'll create a little poll. If you have questions, like a specific nature, please type them in either of the chats. I'll be watching both. Feeling out this first part? Question mark. Alright, wonderful. So we'll see what people think. Okay. 2 people are doing alright at least. That is good. Another couple. Alright. Nice. Alright, if anyone has any specific questions, please do ask. Otherwise, I think we might give... we could give this next part a quick go. Yeah, why not? Okay, because this one will also show up one of our new features that I wanted to show off today, which is sweeping. Yeah, okay. And we'll do some easier examples for Revolve and Loft. Excellent. So we got 4 people saying they're doing it. Alright, that's good for me, at least in the time being. If you have more questions, please add them somewhere, and I will keep an eye out. Right, so the next thing we're going to try and do is actually build this little pin here. Now this is a bit different from the parts we've designed so far because this is showing us kind of a pattern, but this is the cross section. So it's this kind of like, I don't know, trimmed circle cross section, and it goes in this looping pattern. What these exercises say to do, well, not that it's, not sideways, but if you feel like reading sideways, exercise 1 here says, create the part below using swept features. So, and it also says that path dimensions are on the inner edge of the part. So we will be using this new sweep feature that they are talking so much about. So I'll go ahead and press Control N for something new. And we can go ahead and jump right in. So I'll close my data panels. We have some more room to work in. Fusion has decided I don't get to see the ground anymore, which is kind of cool. I really appreciate that. So we can go ahead and click our Create New Sketch, click on the ground, and we can get to sketching. So I think the first thing to do here is going to be to create the path that this thing will follow. So when you're sweeping something, you're taking a cross section and you're making it follow along a path. So I'll actually show off an example of that first. So grab a spline, wiggle all about there. Perfect, and I'll say done. And then what we can do here is put a cross section on the end of this. So if I click, say, here, can I create a sketch from that? Are you allowing that? Center diameter circle? What? No, that's on the same plane. Got it. So what I can do, I think, is, yeah, we'll just draw one regularly. So you want to draw your cross section so that it's kind of, well, running across from your path here. So click front, so we get a nice front view. We can, finish this sketch. Should have done that earlier, actually. So finish that sketch. Then can I create a sketch on the end of that? No, which is fine. Totally fine. So we can go ahead and create a new sketch. This one we want to create on this face. So you can see this is across this, kind of. And then what I want to do is take a center diameter circle, say, put it on that end that we have there. Any size is fine, whatever, finish. And then the last bit that we need to do is actually put this like cross section onto the end of that, I believe. So we can try without, and we can see what it looks like. So to sweep something, we can use the sweep option, which is either up here under sweep. There's not a specific like keyboard shortcut for it, but what we can do is say grab our toolbox and S and type sweep. That'll do as well. You can see there are 3 different types. Those have to do with mesh editing and shell editing or solid editing. We're working in the solid workspace right now, not surface or the sheet metal one, or solid or form. So I think we want to use this blue one always. Then it says select the profile. Profile in this case is this circle. Select the path. Well, that's this path. Yeah, so actually you don't even need to move it, so that's excellent. And then in this case, you can see kind of what it does. It takes our circle, and we can go ahead and hide the sketch. Ooh, I see. Oh, it's run it both ways from there, hasn't it? Yeah, that's interesting, isn't it? Yeah, okay, so we'll move that next time when we do it. But you can see that it follows this path along, forms like a tube shape, nice and 3-dimensional. So we kind of want to do a similar thing, except not with quite a circle, and we also want to do it in this different like pen-shaped pattern. So that's our next goal. So I'll go ahead and actually just get rid of that. Go away. Bye-bye. If I create a new one, is it going to give me my grid back? Certainly is not. Layout grid. Hey, there we are. Don't know how I pulled that off, but we have our grid back. That's good at least. Okay, so we'll go ahead and create a sketch. Create it on the ground plane. Now we want to design this inside bit here. So I'm going to do a really rough sketch first. So I'll grab my line tool with L. Go this way. There's a line there. I know that there's another line on the bottom here, also horizontal. I know that at the end, we have some interesting things going on. We have an arc here. It says this radius is 5 on the inside, so I'm looking back on our design document, the PDF. You can see there's an R5 at the very bottom here. That's the radius of the inside of that. So what we can do is grab an arc. This one, I know the arc end points, and I just kind of want to set up the middle size. So what I can do, sorry, that was very unclear. We know where the arc begins and ends. So what we want is, in this case, a 3-point arc, because we don't actually have a center point that we can click on at the moment, because the center point is really like somewhere in the middle of this space. So we can do this, search for an arc, 3-point arc. I can click on my first point and on my second point, because we know both those, and we can kind of just bubble it out an arbitrary amount. After it's been bubbled out a little bit, we can grab our D dimensioning constraint and click on it, and you can see it gives us a radius. We want something much, much smaller, only 5. So go ahead and click enter. There we are, we have this. Now we're just using our dimensioning tool to set up a whole bunch of other things. So say the length of this, that's going to be, oh, actually, so that's not quite the length of that. So the dimension we're given is it's 100 millimeters from the end of the pen to the center of the pen. So grab our dimensioning tool with D, press the center there, and go down to that point, and we get this. Make that 100. We know that these are of the same length, so we can use an equal constraint. So equal, I've just searched for equal, that's also up here, you can see. That just makes 2 like segments or something identical. So we can say this line should be identical to that line. So that shortens the other one in turn. Then we have the distance of the 2, I think. So that is what we'll do next. Yeah, I think that's fine. Yeah, okay. So I think what I'll do actually, I'll use a symmetry constraint. So I'll slide it down a little bit. I'm going to put a construction line across horizontally here. So I'll whip out my line tool with L, go ahead and click on the end there, and over on the end over here, and roll over it, press X, or click on it, press X rather, turn it into a construction line. Then what I can do is stick the center of this pen onto that line. So grab our coincident constraint, grab that center there, and then this line, if it lets me. No? Oh, I see. Got it. It moved the other line. We need to fix this in place, of course. So I'll fix that line in place. Then we can grab our coincident constraint up here, there. See, it's moved down there. Now, finally, we can use that symmetry tool that I failed to show you earlier. So, symmetry tool requires you, I think, to have a line as your axis of symmetry. So in this case, that construction line that we just built, that's our line of symmetry. So I can jump down here, go ahead to our symmetry constraint. You can also, of course, do this in the search box. Click on the first line, the second line, and then the line that they want to be symmetrical across, which is this one. And there you are. You have them now symmetrically across there. So if I grab one and move it, can I move it? I can slide it that way, but I cannot see the distance. Intriguing. Yeah, okay, there we are. If I grab the endpoints, you can see as I move one of them, they both move together. So that's exactly what we were going for. To make this a bit easier for us in a moment, I'm actually going to make it so that the end of this pen starts at the origin. You'll see why that is in a second. It's just me kind of looking ahead for convenience. So I'll use the horizontal vertical constraint, click on the origin, and that point there. Wonderful, it's made it nice and vertical. Now our last bit of freedom is just this sliding. Oh, and also that can pull the circle somehow. Yeah, okay. So you can kind of rotate the circle like that, which we don't quite want. So we also then want to pull that in a bit. Am I allowed to pull that back in? Let's undo a bit. I've kind of broken that, haven't I? There we are. And we can set those a certain distance apart. So distance tool with D, and the gap between those, oopsie. The gap between those, click and click, is going to be 2.5 millimeters they've given us. So we'll go ahead and click on that. Wonderful. That is finally fully constrained. That was a bit of a faff, but we got there. So you can see nothing can move anymore. Now there's one feature that we've not got, which is this radius of 10 here. So let's go ahead and add that in. You could do this with an arc. However, I think this is a good place to use a fillet again. So you can grab this sketch fillet is what that is. You can also, when you're searching for it in the S toolbox, if you type fillet, it's, yes, this one here with the lines, that's for sketches. Then you can just click on the two lines that you want to fillet together, which are these two. And the radius of that one is 10. So radius of 10, do the same thing here and there. Oops. Fillet here and there. 10. Alright. Now, that is got a lot of constraints going on, but if we go ahead and finish that sketch, you can see that's about the shape we're going for the inside of this pin. So that's about right. Now we just want to sweep this profile along it. So what we want to do, we'll draw our profile now on this plane. So if I go ahead and create a new sketch, we don't have any surfaces to do so yet with, so I'll just create a new sketch. I'm going to do it on this plane. See that flattens this design out. And we can actually use this endpoint here, which will be very helpful for us. So, with this endpoint, I think what I'm going to do is, so we'll design this end. I'm thinking about how I might best do that. Okay, so let's just build a rough shape first, and we'll constrain it down. So, first we'll grab an arc. So, search for an arc, grab our 3-point arc, that'll do just fine. There we are. Let's connect that with a line. So grab L for connecting with a line. All connected up. Now we have a solid shape at least. Now we need to constrain it a bit. So D for the dimensioning. The radius here is going to be 2.5, it looks like. So that's pretty big actually. And it's going to be from here down to the edge of that, 3.5. So if we click here, now you'll notice if we go and click on this circle, it takes us to the center point to measure to. Now that's just a really sneaky hidden feature that should help out a little bit. If instead, when we do that, we grab our dimensioning tool, unselect everything, grab our dimensioning tool, click on this line, then we right click out in space, we can see we have a couple of options down here. So there's either pick a circle or arc center, or pick a circle and arc tangent. So we actually want the tangent, which is the outside surface. So we pick arc, circle, tangent. Then we can click on the outside of this here. Then you see we get that measurement from all the way out there into in here. That's what we were going for. We can type our 3.5, that's what we're given in the design, and constrain that up. Now, the last thing you'll notice is that this is all just kind of vibing in space, floating about. Wow, I don't know why Fusion's getting funky with me today, leaving that outline. Regardless, we want to put the center of this flat bit in on this end point of that curve, in like the midpoint as well. So we can do a couple of things. Actually, we can probably do this in one step. A new constraint we might not have seen is one called the midpoint constraint. So that can help you fix something to the middle of another line. So to show that off, I'll keep it slightly off the middle point. We can search for it, or it's up in this menu, so I'll show you in the menu. Up here we have midpoint, looks like a little triangle, and it says it constrains the point or object to the midpoint of another object. So we can say that there, that point, we want to constrain to the midpoint of this line. And then you can see, zips right on in. It's both centered on that line and now touching the line, so it's kind of like a coincident and a symmetry at the same time, sort of. So it's locked onto the end of that line. Perfect. I think that is our finished profile. So we can go ahead and say Finish Sketch. Take a look at it. It's looking pretty squirrely out here, but we can fix that up, make it look much better by sweeping it. So we can press S for search and then do sweep. We want to do the first one, then we want to select the profile. So the profile is like the cross section, so that's the sketch that we drew here. And then the path is our path here. And zoop, there we are. And just go ahead and keep the rest of the defaults, click OK. And voila, we have our pen. And you can see that it's nice and flat on the inside edge, and it follows the path all the way around the outside. So that's a semi-advanced-ish example of where you'd like use a sweep. How are people feeling about sweeps. I'll ask a poll, and we'll see how people are doing. Poll. Have people? Well, okay. Well, let's see. Let's get it. I was about to ask, have people been swept away? Because I'm feeling, I guess, too playful for my own good. So we'll just go with how are people feeling about sweeps? All right. We'll see how people are doing there. And if you have any questions, feel free to ask them. Wonderful. Nice. Ooh. Okay. So for Isaac, can I help clear up sweeps? Annie, do you have any specific question or thing that's catching you out with them?
I don't know how you did the cross-section bit.
Ah, the cross-section bit. Which bit of making the cross-section bit?
Well, I haven't been able to concentrate on it, so I can't do that on making it.
Okay. We'll take a quick look at how I did that. So we'll jump back real quick. Click on the sketch. Have you gotten to the point where you're creating a new sketch on like the I guess what is that? The ZY plane?
No, I didn't get that bit.
Okay. So real quick, I'll show this off. So we'll go actually back in our timeline before that sketch existed. I can say finish. Go back to right after our first path sketch. Where is my first path sketch? There it is. Okay. So I've placed the end point of this kind of on the origin here. So you see if I show my origin, I get, there's this plane that I can build right there. So you can either show the origin, then right click and build a sketch, or when you click to create a new sketch, even if your origin isn't showing, click to create a new sketch, you get the option to pick a plane. So I just picked this one here, which is like perpendicular, I guess, to that path. So then it moves into this view. And then from here, I can go ahead and build the arc. So here, I did S, and I had an arc. Well, that's very different looking. Arc, there we are, 3-point arc. Just build something really rough looking. There we are. Connect it with a line. That line needs to be vertical, so we can go ahead and say horizontal vertical. Then we can grab our dimensioning tool with D. Go ahead here. The radius of that is 2.5. And what else can we constrain dimensionally? We can also say constrain this edge here, so this flat edge, out to the outside. This was the bit that's the different feature. So normally when you click here and then you click on the curve, it'll measure to the center point, which you could do. You could just divide the number they've given us by 2, and that's the radius or whatever. But we probably want something slightly different, which is to measure out to that outside edge, like they do in this diagram. So to do that, when you do the dimensioning, so press the D for dimension. Once you click on one, then you can right-click. So this is not a left-click, right-click just in space somewhere. Then you can go down and click Pick Circle, Arc Tangent. So that's the tangent instead of the center. Click on that. Then if you click on the arc, you see it goes all the way out to the outside. Then we can put in our 3.5. So now that shape is fully constrained, but it's still floating about in space. So it's kind of sliding around. Then we want to put the midpoint of this flat line on the end of this path. To do that, what we can do is grab our midpoint constraint, which is up here. It looks like a triangle. Then we press on the thing that we want to be the midpoint, which is this end. Oh, whoops, I already had something selected. So go back. I make sure I have nothing selected by pressing escape. Midpoint, click on the point here. Then we click on this middle line here, and it lines up the middle of that line with that midpoint. And that's how we have that like sketch. That was a bit quick. Does that clear up your confusion?
Yeah, that's good.
Okay, awesome. Happy to help. And yeah, if you're still stuck in any bit of that, yeah, I can help afterwards, for sure. Awesome. Cool, yeah, so finish sketch. Then we do the same thing we did before, where we just took our sweep with S, sweep, and profile, and then the path. Click on path, then path, then OK. Wonderful. All right. Cool. All right, yes, so if you have more questions about that, definitely feel free to ask as we go along. I think I'll do a real quick whirlwind tour of some of these other features. So these other ones I don't necessarily have a part to show off, but I'll go ahead and create a new document. We'll take a look at a couple of other ones we haven't seen before that are very useful. The first of which is a loft. So this picture shows it quite well, actually. So while sweeps, you can take one profile and move it along a whole path. Lofts help you move between like different shapes, I guess. So maybe, say, you've seen at some point in your life a lamp that has a circular top of the shade, but then it's a square at the bottom. So we can make a little lampshade like that. So the way we can go about that is, say we have a square bottom, so I'll do create a sketch, create on this bottom plane. I'd like to center rectangle, since I'd like things to be centered here, so I'll search, and I have pinned to my shortcuts a center rectangle. I'll grab that. We'll make it a square, actually, so 100 by 100. That's probably, oops, partially realistic. Nicely done, Brooks. You didn't constrain the other dimension. So I'll press D after the fact. Constrain this one to also be 100. Oops, I made that 1000. That's why that's so ridiculous. 100. There we are. Much better. So here we are. We have our square bottom, and we're done with that sketch. That's one of our profiles. Now, instead of extruding things, how lofts work is you have several profiles, so like shapes around the outside of the thing, and they're separated somehow in space, and then the loft will connect them for you. So what we want to do is something a bit sneaky. We want to create another sketch that is just floating in space above this, but by some specific amount. So to create something floating in space, what's very helpful sometimes are offset planes. So you see, this is a face here. If we right-click on this, one of our options, in addition to like creating a sketch or whatever, is creating an offset plane. So if you do that, you see here, you pop up this yellow plane, and you can drag it up and down a certain amount. And you can build sketches on this plane, and it's just for construction. So I'll move this up 60, why not? So that's 60 above. Then what we can do is right-click on this construction plane, and you can build a sketch there. So right-click and then create sketch. And now we're up here. It looks as if we are on the ground, but we're actually floating up in space a little bit. So let's build a circle here. Go ahead and take this. That seems decent. That's a bit silly. Let's go shorter. Let's say 80 as our diameter. This is not constrained because I haven't actually constrained the diameter. Fair point, my friend. All right, there we are. 80, enter. And we'll go ahead and finish that sketch. Now you see, once we're back in 3D space, that these profiles are kind of floating apart from each other. Now, if we want to connect them, that is what the loft is for. So, with the loft, we can just grab here, loft, and click on the bottom profile and the top profile, and you can see it's gone ahead and tied those up for us. Now, it's been a bit squirrely around certain bits of it, if I'm being honest. Maybe, however, that's just because of the way that we've gone about it. Well, okay, hold on. Let's take a look at the final product first. So here we are. It's actually pretty decent looking. I think I was being a bit too critical right off the bat. Yeah, but you see, maybe you want those a bit farther out. But if we wanted to say change that, we could make our circle in the middle a bit smaller. So if we grab our second sketch, make this a bit smaller, say only 50. Make it a bit smaller. Finish sketch. CAD goes ahead and updates that for us. Yeah, so there we are. That looks a bit more realistic-ish. So there would be like our kind of like lampshade-ish shape. Another really cool thing you can do with lofts is guide them a little bit. So if we go to edit, you see that there are these couple of guide types. You have rails and then a center line. So I will try and show you what those look like. So yeah, we'll do center line first. That's the easiest. So we'll go back here on the right. I will hide the body, and I will show both of these sketches, because we need to kind of connect up to these sketches. And I'll build a new sketch, so I'm using the create sketch function on this phase here. So this is just on the axis. From here, what I want to do is build a line. I'm going to make this curvy, so I'm just going to use a fixed point spline. Click there and there. That's not quite what I wanted to do, was it? You know what, let's do an arc actually. So, arc, 3-point arc. So click there, center, and center, so it has to be in the center for both when you're doing a center line. I'll make it a bit curvy. I'll leave it unconstrained. I'm not too fussed about precision at the immediate moment. And then, if I reshow our body, and we go to edit our loft, so, oh yeah, also, when we go to edit our loft, so you see if we double click on this, double click on that, our sketch here is grayed out, and we can't actually select that center line. That's because in history, we created this sketch after we created the loft, but Fusion's very kind to us. It lets us literally just take this sketch and say, that happened before the loft, and we can convince it that it did. So now, by just clicking and dragging it over onto the other side, and click back on the loft, and now we see our center line through the middle. So I can say, okay, guide type, center line, and I click on this rail, and then there we are. We see our very funky shape where the center of that loft is now following that arc that we have there. So maybe this is your lampshade from the Modern Art Museum. That looks very special. Right, so that's one example. One that's probably a bit more helpful with lofts instead of the center line one, because the center line, it kind of sort of acts a little bit like a sweep because you're following a path. One that I find personally more helpful, so go ahead and just destroy that sketch, is the guides around the outside. So I'll show you what that looks like. So again, we'll hide the body, keep the sketches visible. This time, you need to connect to the outside of both of these points. So to connect to this, you see this is a circle, so we can actually snap to anything there. Just to make our lives easier in a second, what I'll go and I'll edit this. I'll put a construction line, so L for line, and draw it from one side to the other, and make that a construction line. So click on it, click X. And I managed to delete it. Click on it and click X, and I click off of it. Oh no, it's fine, it's fine. Finish the sketch. So you see now there's that line to the middle. So if we go this way, we'll look at it from the front actually, just for the sake of it. And from here, now you can see this little line we can click on there, because that's an intersection now between the guideline. Say we want our lamp to have a bit of a curvy look, so it goes down a bit as a circle first, and then comes out into the square shape, if that makes any sense. So I'll show you what that looks like more practically. What tool do I want to do that with? So we actually want to create a sketch. So sketch on this face. We have a number of tools available to us. Trying to think what would be the nicest shape here. And I think I'll do a control point spline. We haven't seen one of those before. I think this is what I think it is. So we can specify our first point, which is up here. Then specify our last point, which is down there. And I see what it's done. Got it. So when you're doing a control point spline, you click on one, and then you click on the next one, and it kind of does an arc between the two, if that makes any sense. So by moving this control point here, you're kind of flexing where that curve goes into. These things are very intuitive. They're not like terribly, I guess, formal, or they're a bit hard to describe like mathematically, I suppose. Although obviously the computer does it somehow. But these are, you might see these if you've worked with, say, like an Illustrator or Inkscape software before. We'll say Inkscape later. So like they're graphics editors. These look a bit like those lines that they've got. Excellent. So that's a guide rail enough. So I'll click Finish, Finish Sketch. And we'll take a look at it in 3D space, make sure it's connecting our two, which it is, which is wonderful. And now we'll drag this sketch again before our loft so we can use it. And then we go to our loft. And what we want to do now is take guide type rails and click on the rail, which is now this sketch. Now you see this one's a bit squirrely. It's gone ahead and not quite listened to, well, we wanted this on both sides realistically. And it's not quite done that for us. So we can actually go back and tension edges. No, it's not going to change anything for me. Add some more rails. So sometimes it'll figure this out intuitively. If this were a circular shape, I think it would have figured that out and applied it all the way around. Since this is square, maybe not, but that is alright. Because we have tools for this. So here we probably want a circular pattern because we're kind of taking this guide and we want to put it 4 times around this circle. So I can search for a pattern, circular pattern, which is the second option here. Select the object type, which is, ooh, I wonder if it'll actually let me even select it. Sketch. Maybe. Let's find out. So circular pattern. Am I allowed to select that? No, I am not. Very exciting feature, maybe. Not happy, and I can't imagine you're happy about faces. Okay. That's fine. We can maybe mirror it, potentially. Or we can go back into our original sketch and just add it on both sides. I think I'll do that one first. So we can hop into our sketch, double click it, And here, what we essentially want to do is just take this, mirror it onto the other side. So press our search tool, search mirror, and this first one's the one we want. Select the object, which is that line there, and then mirror line is going to be this middle axis, so we'll turn on our origin real quick. Click that middle axis. There we are. It's on the other side as well now. Okay. Finish sketch. We can see what this looks like. I think this will still give us a bit of trouble, maybe, or maybe it won't. We'll give it a go. So we can go back to our loft, and guide type, rails, select both of these rails. There we are. And click OK. Ooh, exciting. Of course, bodies are hidden. And then we can take a look at it. And if we take a look around, you can see, yes, so it's not following our shape on this side yet, but it is following it on this side. So we could do the thing where we just replicate that around even further. Yeah, there's a way to do that. Why not? We'll take a look at it. So we'll hop back before our thing, and we'll show our sketches again. And what we're going to do here is just, we want these same sketches, but on this other plane. So I'm going to grab this sketch, and I'm going to right-click and say duplicate, which should be an option somewhere. Except it is not. So maybe I'll copy and paste. And I also cannot do that. Okie dokie. Does anyone see duplicate? I do not. Alright. Well, you can duplicate objects, but apparently not sketches. That is good to know. Coolsies. Well, I think for the time being, then we'll leave this, because if you manage to rotate this around the outside, then you would be able to see kind of what these rails look like. You can see that lofts are much more finicky, especially when you're using rails, because sometimes it gets picky about how many of these rails you actually need. In this case, we're able to get away with this amount, and it looks pretty decent from this profile. Hello? Go away. There we are. From this profile, we would just need to also polish it up in this other way as well. But I suppose I will leave that as an exercise to the reader, because we're running a bit low on time, so we'll continue onwards. Alright, so that's how lofts work. I'll ask real quick if there are questions about lofts. So, how are people feeling about lofts? And you can also do more than just two profiles as well. So you can put up a third profile and then just select more of them when you're here, so you can select more profiles. That is totally fine. Yeah. Connected direction. Maybe direction is just something a bit nicer what we want. Yeah, maybe not. Okay. Alright. We have one person that said they're feeling okay about lofts. The rest of the jury is out. Understandable, if I'm being honest. Yeah, they're very, very helpful for some things. But they are definitely a bit finicky to work with. So I'm sure we'll come back to this at some point. In all the things that I've ever had to 3D design, I've never actually needed a loft, but there are certainly cases in which they're lifesavers. So it's good to know about them, and basically just know that you can connect different types of shapes at different elevations, kind of. And it connects them between semi-smoothly. Awesome. Cool. That's lofts real quickly before we jump into like the 3D printy / laser cutter bit. We'll take a look at revolve, which is a nice helpful one. That one's actually pretty easy, I think, relatively. You know what? Let's do an example very similar to what they've given there. So if we create a new document here, and we'll create a sketch. This time I'm going to create it on the side. We'll create some sort of interesting looking shape here. I don't really know what that shape will be. Maybe we'll have a nice shape that comes out and it goes down. Maybe we'll go out a bit here. Oops, oh, I managed to click finish on that. Didn't mean to. Down there, down there. And we'll connect that with an arc. So S for an arc. And grab our 3-point arc. Click and click. And out. Something like that. Sure. Beautiful. And we'll move that a little bit farther away. Hello? Can I move you, please? No, it does not want me to move it. Got it. Okay, that is fine. I'll select all of them and move them. Move them over to the side, say there. Then what you can do with some profile like this is you basically just spin it around an axis. So I'll leave that unconstrained. Bad practice normally, but fine for something quick. I want to spin that around this blue axis in the middle, say. So what I can do is select our revolve tool, so I can search and do revolve. Again, we want the blue revolve. Click on the profile, which it already selected for us, then the axis, which is this blue axis here. And then you can give it a number of degrees. So let's say if you only wanted to go 270 degrees, you could just type that in, enter. Now you have rotated around the blue axis 270 degrees our profile. So that's another way to build some like pretty interesting looking shapes. So that's good for building anything that's like circularly symmetrical. You only have to build half of it, and then you can just spin it around a whole circle, kind of like we've done here. So maybe like the base of a lamp or something else like that. Cool. All right, that was pretty whirlwind. So let me know if that was a bit too fast. How are people feeling about revolves? And I did go through that very quickly, so if anyone didn't get all that, let me know. Any specific questions either? You have 2 people feeling okay about revolves. How are the others doing? Okay, more. Excellent, excellent. Cool. Alright. Yeah, revolves are much simpler compared to, like, lofts. I think lofts are realistically probably the most complex of, like, these options that you have for creating solids out of sketches, just because they're very finicky to work with a lot of 2-dimensional things in 3 dimensions, which is what you have to do to prepare the loft. But very helpful. Cool. Alright. In that case, I think what we'll do is transition real quickly and take a look at how you might 3D print a part. So, and I'll keep this very simple. We'll probably do a more complex 3D printing thing later, I think just for the sake of time. So say this part here, it's really quite nice, maybe, depending on your opinion. Let's say we want to 3D print this. So the first thing to do when you want to 3D print something, I'll turn off that sketch, it's nice to look at, is export it to a format that 3D printing software can understand. The universal format for this, basically, is STL, which forms like a little mesh, so you'll see what that looks like in a second. So if you go to File, one of the options under File is 3D Print. So if you go down the options, you can click on the 3D Print option. Then it says, okay, make a selection. So I'll select this object here. I can click on it. Takes a second, and turns it into this absolutely horrific looking mess. But this is actually what the mesh that the 3D printer sees looks like. The reason this particular mesh looks so nasty is because if you look real close, everything is made out of triangles. Everything has to be in this particular format. So with a lot of curved edges, that means you need lots of triangles to make them appear rounded. You can also see to change the number of triangles that are involved. So this would, like, say, simplify your file. You can turn the refinement down, so you can say low refinement. So now these things are objectively less round, but it's also a much simpler mesh. We only have, you see here now, around 19,000 triangles, whereas on high refinement we had 62,000. So depending on how smooth you need your part to be, select whatever refinement seems appropriate. Here, you can send the output either directly to a 3D print utility, which is what I currently have done for Prusa Slicer. However, I'll uncheck this because it's a bit more helpful to see how this works. So if I uncheck it, I can just click OK. And then you can see it's giving me an STL file to save somewhere on my computer. Hey, Kerbal Space Program has news. Thanks, Steam, for giving me that. So where do we want to put this? Say I'll just put it on my desktop. I'll call this, I don't know, Curvy Boy. Very descriptive. So we'll go ahead and save that file onto my desktop. Then, the next thing you have to do is move to some sort of slicing software, is what it's called for 3D printers. It's called that because it turns a solid object into a bunch of layers that the 3D printer can then turn into a solid object, like follow its instructions to do. So in my case, I'm using something called Prusa Slicer. This is free. You can install it on any operating system and works very, very well. Another popular one is called Cura. I've not actually dealt with that one before, but that's another option. But you see, this kind of looks somewhat similar to like our environment we were seeing earlier, except now it has customized for my 3D printer. You can pick your 3D printer in this drop down, and it supports many more. You can do add and remove. The one that I have is a mini, so it shows you how big your bed is, and then we can go ahead and put parts on it. So to put parts on it, in this case, you just use this add button up here. Then you go ahead and click what you want. So I've got a goose actually, but we'll do our curvy boy since we've actually seen that one. And you can see, wow, it fills up most of the build plate, but it manages to fit on quite nicely, which is fine and wonderful. So once you're here, then you can make other adjustments. Say if you wanted several of these, you can click the plus button to add more of them. And this arrange button here, or Shift A, so that just spreads everything out so nothing's colliding. That's very nice. So say if you want to print 2 of them, you could do that. Then you can select a bunch of different options. I think what we'll do is we'll have at some point in advanced 3D printing session, because there's a lot you can do in this program and we don't have a bunch of time at the moment. So instead, what we'll just do is keep the default on everything. Go ahead and click Slice Now. It takes a second, thinks about it, and then it comes back to us with this. Oh, it's still slicing actually. There we are, now it's done. So you can see it's color-coded, and we also have this big slider over here that lets us go up and down through the layers of an object. So you can see the first thing it's going to do is print that base, and that base is a solid infill, which means it makes a solid place there. As you go up, it actually starts to make this shape hollow using something called a gyroid infill, which is something special to this slicer software. So that's that red weird pattern that you see here in the middle. And if I zoom in close enough, you can see like these are all individual little like filaments, and that's kind of what your 3D printer is printing. So as we go up, you see that red pattern. It's a bit funky, but it kind of just fills in the space inside, makes it strong, but without actually making it entirely solid. So it saves you lots of like plastic when you're printing it. And then of course, once you get up to the top, or at least of that, it goes and puts on a face. So there's a solid infill, and then you have eventually a red, which means the top solid infill. You can just see that in this color key up in the top left. Then of course you go up a bit farther, and you can print the rest of that feature there with that little notched bit. And that's basically a very whirlwind tour of how this like 3D printing software works. There's a bunch of different details and things to go over at some point. I think I'll say that for an advanced session, but I guess some other easy things to go over are here down in the bottom right next to the export G-code. So G-code is the file or the file type that actually tells your computer that actually tells the 3D printer how to build this object. So that's the one that you'll be uploading to your 3D printer is this G-code, or the 3D printer in the iForge for that matter. And then here it just gives some extra info. So here it's going to use 20 meters of filament, which you can calculate how much that costs. So here it is, well, I actually have no idea what units that's in. It costs 1.15 something. Might be dollars, might be pounds. And it tells you the mass of it, and also gives you your printing time. So this one here, you can see it will take 6 hours, 35 minutes. Another easy thing you can do up here is you can change the print presets in this particular software. So the higher up you go on here, the smaller these numbers are. That's the height of each layer. So if you make really, really, really small layers, you're going to end up with a really nice polished final product. If you go for really big ones, it prints faster, but it's going to look a bit rougher. So if I go ahead and click that and then reslice, it's going to think. To be honest, it looks very similar, at least from a distance. But you can see now it only takes 3 hours, or about 4 hours actually. And that's because each one of these layers is thicker than before. So if you take a look at how thick those layers are now, I'll zoom in a bunch so you can see. So there's how thick those layers currently are. If I make them really fine, say ultra detail preset, go ahead and slice that. Now I just realized that's going to take ages. Yeah, look at how tiny, 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 tiny those lines are. It almost looks entirely solid across the side. And this one will take, well, we'll wait for the slicing to finish and for it to tell us. It takes longer than more layers and stuff you tell it to calculate. This might actually take ages. There we are. This will take 1 day, 4 hours, and 36 minutes. So, pick pick an appropriate trade-off between your print quality and the print time that you want to spend on it. Yes, there's a bunch more to go into. I think we'll say that for another session. In the meantime, do people have any questions about this whole process, how we got it out of Fusion and everything. The way that we got it out of Fusion, remember, is you go up to File, and then 3D Print, and then you can click on the object you want to 3D print, and pick your refinement, and then OK to export the STL. And you can just import that from this other software. So let's see, poll, how are people feeling about 3D printing stuff? Got it? Some thumbs up. Yeah, 3D printers are fantastic. I got to play with one over the summer for some project I was working on. Well, actually, I think I showed it off before the project I was working on. It is out and not in this one, so not in the default project, but here, yeah. So the project I was working on was this chunky one in here, and I 3D printed that whole thing. Wow, it does not want to load. There we are. So you can see I built lots of different parts and assembled them together. Assembly. We'll have to have a session on that as well at some point. But assembly is quite simple. So yeah, that's the bit that I've 3D printed before, which is very nice. Yeah, we'll do real quick then our slicing for... Oops, no, don't save that. Slicing for laser cutting, and from there I can also show very, very quickly how you can do some basic assembly, which would be nice. Don't save, don't save, don't save. Goodbye, all of my hard work. Okay. Jump back to home, back to a default project. I mean, not that it matters, actually won't be saving things. Okay. So, finally, I want to take a part that I've already designed at some point. So, I'll load that in. So I can go ahead up here, say open, from my computer, and I put it in Fusion, and it is plate holder with suspender version 2. So this is something I actually made in a different CAD software over the summer. It holds a plate in here, which holds bacteria. So it's like a plate for it has a bunch of little wells for holding liquids with bacteria in them, and you can run experiments. And then what you do is you connect these bits here, so these holes on this floating tray, and then the holes that are coming up from this base with springs. Then you put motors with weights in either of these big holes on top of this floating tray. And what that can do is shake this tray, and it's pretty cool. I wish I had the video to show it to you. Couldn't find it immediately, but point is, this part here, I was originally planning on 3D printing, right? But I ended up laser cutting it because that saved us a massive amount of time, and it also helped us fit things onto the print bed. So I think actually, so let's go ahead and see how big this thing is. So if I close that, we go up to File, 3D Print, bottom bit, okay, body 2, sure, whatever. I do not mind what you were called. I promise I'm organized. Okay, go in here, new project, yeah. Add it, just so we can see how big this all is. Body 2. So you can see that's quite large. It only barely fits on that print bed. I think when I was in the iForge, it actually didn't fit on whatever printer they were trying to print it on. But also, you've got this really big overhang, which in this case, it's probably at an angle that the 3D printer would be able to handle fine. But if, like, for example, let's put it back on the default setting, which was quality. Slice now, how long would that take? So that takes about 3 hours to print. So, not a massive deal, but 3 hours of time when, in reality, we made this thing with a laser cutter. And with the laser cutter, we made it in 20 minutes or less. Maybe around 15. So, I'll show you how we can split this 3D part into two-dimensional parts. Because what laser cutters do is they take a two-dimensional sheet of material and cut things out of it for you. So I'll show you how that works real quick. So I will... Deciding which one. Okay. Vote, because time means we'll probably only get to do one. Which bit would you like to see prepared for laser cutting? So turned into just like flat segments. Would you rather see this top floating bit or this bottom bit? Vote now! I don't know. Just say in the chat top or bottom, whichever one you'd like to see split up for laser cutting. Top one? Alright. I think that's a decent choice. Yeah, so... Yeah, the bottom one, if we were to do that one, we would just kind of split it along this axis, so you have these floating bits separate, and you build little holes here so they like slot in as notches. But this top one is a bit tricky because you see, yeah, it's got lots of different things going on. So I'll show you how we can build that. So in the meantime, jump over into my tree over here, hide body 2, which is that bottom one, and we'll just focus on slicing up this top one. Cool. So what we want to do is split this into two-dimensional segments, kind of. So in reality, what I did was this was a 3-segment piece. I had one bit on the bottom, which had most of this outline, did not have that piece, and did have this little holding bit, so that prevents trays from falling through. The tray from falling through. I had the middle segment, which had everything except for this little bottom tray, and then this top bit, which was just like a little outline holding on top. That's very vague. I'll show you in real life. What you can do if you want to slice things up like this, you can right-click on a face. You can get an offset plane. We've seen this offset planes a little bit before, but now, instead of giving it any offset at all, I'm just going to keep it at 0 and hit enter. Now, what we can do is cut this shape, this body, into several bodies at that plane. Actually, let's do it all in one. So my other plane was at the top of this, so if I right-click on that, offset plane, and then leave that be at 0. I see. That's a bit squirrely. We'll see if it likes that. If it doesn't, we'll fix it. Now we can encounter something new we haven't seen before. It's actually up here. You can see under Modify you have Split Body. So this creates new bodies by dividing a selected body by a face or a plane. Well, we have some planes here to divide it by. So if I go ahead and get that, so I'll do Split Body, click on that. First thing we do is select the body to split, so that's this whole body here. So we select our splitting tools. So that's going to be this plane and also this plane. Yes, so you can see, oh, actually, if I unselect one of them, does it give us the option? No, okay, so it just automatically extends it for us. So Fusion 360 is pretty smart, and it will extend, if you want to split this body, it'll extend this plane. You can see these big red circles where it cuts it. So that's all the way around. So that'll pop it into 3 segments there. So if I go ahead and click OK, shop, we can hide our construction planes. And now we have 3 bodies here. So if you see, I can move by pressing M, click on that one, slide you, actually probably go to the top, this way, that's the wrong way, zoop, trying to get my cube just oriented right. I'll slide you up, so you're up there. Middle segment, okay, that's fine, sure, whatever. Middle segment is this one here, and I want to slide that one down, so M, slide that down by, let's do -100, because I think I moved the other one by 100. Did that not work? That did not work? I must have clicked enter too quickly. Whoopsie. Okay, slide that down by 100. Oh, intriguing. Okay, that's not actually moving that object, is it? Oh, am I just selecting the face and showing up? Okay. Maybe I have to select the whole body again. So there I select the whole body, body 4. Then I do M. Sorry, that's my bad. Then I'll slide it this way by 100. Okay. Okie dokie. Wonderful. So now if we look at this from the top, you can see here we have our 3 different profiles. And each one of these, very importantly, if you look at them in 2 dimensions, is entirely like, well, there are no vertical features, if that makes sense. So it's just an outline all the way around. It's as if we made one sketch and just extruded it upwards, right? If you can see that, yeah. So there's no like no detail we lose in 3 dimensions. So the final thing to do, when you're using a laser cutter, you want to export things as a DXF file. And to do that, well, Fusion can export sketches naturally as that format, but these are, for the keen-eyed among you, not indeed sketches. These are 3D objects. So how do we turn them into sketches? Well, very easily, actually. So what we can do is create a new sketch, create this on our bottom plane, and what we want to do here is press P for project. Remember, before we projected geometry, so that takes some 3D feature and puts it onto our sketch plane. So here, select that entire object, this entire object, and this entire object, and click OK. And then we can hide all of these bodies, and you see in our finished sketch, we have sitting here, why are they still selected? Is that the issue? Well, you can see lots of these little circles because I guess they've been projected down. But you can see everything's been turned into these two-dimensional shapes, which is exactly what we were going for. Mostly what we were going for. Yes, exactly what we were going for, sorry. Yeah, all good. Yeah, so now that we have these, what we can do is grab our sketch, which is here, which is everything. If you right-click on this, you can see Save as DXF, and that is our outline file that the laser cutter will use. So we save it as a DXF. I will say this is the tray. Put that on my desktop again because I'm very organized. DXF file saved. And now, what they'll have in the iForge, and it's a free piece of software, is actually excellent for a bunch of things. I use it to make like posters and stuff, is Inkscape. It's meant for dealing with vector graphics, but one of the things it can deal with is DXF files. So say in the real world you might have some size of material. So say you've got, to build this piece, a 200 by 200 millimeter square of MDF, which is medium density fiberboard, or something like that. So I can go in here, my document properties, and I can say, okay, well, I would like to have something that is, 200 by 200 might be a bit small. Let's say 400 by 400. So 400 by 400 millimeters as my units. You can see I select millimeters over here as units. That just builds a canvas that's 400 by 400. That's under document properties. Then here we can import the file, the DXF that we just got. So go under file, we can do import or open. I will do import because I want to put them in this document. Then I just go and look for it, which is tray, okay, open, keep the scale. When it comes to the method of scaling, you want to read from the file. So just use whatever the file that Fusion exported, use that scale, that's fine. And you don't want to change the scaling at all here, keep that as is. Wonderful, okay, then you click alright, keep it as default. Include it as an editable SVG, this one you just keep as default as well. And wonderful, got it, I see nothing. Perhaps it's a bit big. Yep, okie dokie. Right, so we have learned a lesson. DXF files, and I have actually, this is something that I knew, and yet I got a bit brave. So DXF files don't actually include a scale in them. So it's just a unit. Most laser cutters will use millimeters as their unit, but when you imported it here, it seems like Inkscape interpreted that as meters, probably, which is why it was so massive. If we go here and we click on our tray, this time we just do a manual scale and leave it as is. I think that'll work all right. Okay, yeah, there we are. That's better sized. So you see we have this group of 3. They all come as one part. Inkscape, I mean, I probably won't spend a massive amount of time teaching Inkscape because there are other people who do it better, and it's just like a graphic design thing. You only use it here and there. But some useful things are, these are all a group, as you can see. So they drag around together. If you click on one, everything gets selected. But you can also do Control-Shift-G, maybe. Just kidding. Radeon has decided, no, that's my keyboard shortcut. So instead, you can click on it, go up to Object, and Ungroup, which is Control-Shift-G, as you can see. Just my computer doesn't like that, of course. So you can ungroup it. Now you have all of these things as individual outlines, you see. And what's very helpful sometimes is these laser cutters, you can tell them to cut things in different orders. You usually want it to cut the small inside holes before it cuts the outside holes, because otherwise the part can move. So imagine if you cut it out of the whole sheet, then it moves around as you're cutting the things inside of it. That's not what you want, so you want to cut this from inside to outside. So you can kind of set up a bit of an order if you want. So say, if you zoom in, say red things are the first things to cut, so you have your color red down here, so you can click on, say, this circle, hold down shift to select several things, just select all the circles that you want to cut first, and you go ahead and give those all one color. So this will all be the first step. So the first pass, we're going to cut all these shapes out, and then we can just go down here and shift to set the stroke of the line, click red, then you see they're all red. Then from here you can kind of continue that same process with the other lines, and then in the software it'll be very easy when you import this DXF, which you can just do here. So you can do save and then change the save as type to DXF. So you can change this one here, DXF. When you save that file and import it into the laser cutter, it'll say, okay, what settings would you like for this particular line? So you could say for red lines, please cut those first and cut through at full power or whatever. So this will be, we'll have a more advanced, I think, manufacturing session probably in second semester, hopefully once we can get more people in the iForge. And then there I can actually show you how you do laser cut these things. But the point is, like, this whole thing here will be made in 10 minutes or something. Laser cutters are very, very, very fast compared to 3D printers, so it's good to know how to do that as well. Alright, that brings us to time to the minute. I did kind of fly through that last section, so I will here and create another poll. So, poll, how are people feeling about the laser cutting stuff? Alright. Yeah, so ask any questions that you might have. For the people who are relying on the timeline that I've given of 4 to 6, feel free to head off, and I will see you next week. If there are people who have questions, however, feel free to stay. I have nothing to do. I feel like at the end there, I did go through things quickly, so if you have any questions about the specifics, or just unrelated questions that are like kind of on the topic, I'm here to answer those. But otherwise, thank you very much for coming along, and I'll just wait and see if there are any questions. But yeah, see you all next week. Yeah. Thank you, happy to help. See you.
Hi Brooke,
Hello.
I've got a question.
Alright, how can I help?
Right, is it alright if I share my screen?
Yes, I think you should be able to. If you can't, just let me know. I'll stop sharing mine so you can share.
Anything else? Oh, there we go.
Yeah, I think it's present now. Any luck?
Can you see it?
Not yet. It might just be loading for me though. Or maybe it's not a fan. Aha, there we are. Yes, now I can see. Wonderful.
Brilliant. Okay. Right, I'm gonna maximize the screen. So what I'm trying to do here is to add a hinge
Okay.
over here. The thing is that I don't know how to sketch from here because normally I just do like tangent plane, but because this is not a conical surface, so I don't know how to put a plane on here so I can draw it.
Okay. So which face would you like to sketch on? You like to sketch on the face that you have highlighted currently, but in the floating bit?
What do you mean? Like which bit I want to sketch in? Just this bit, like, do you see the dented bit?
Yes, yeah. So I guess, sorry, from which angle then do you want to sketch in that dented area? From the top or from the side?
I don't mind actually, but do you know how to, like, if I want to sketch on this surface, how do I do it?
Yeah, okay, so that one's easy enough. I think if you want to sketch on that surface, if you actually just right-click on it, and then you click on Create New Sketch, which, so, yeah, maybe not quite that one. I think it was 2 options down, a bit sneaky.
1 second.
Yeah, no worries.
No, let me just go back. Okay, so if I click here,
Yeah, and then you see the second option down on that big list is Create Sketch. I think that should create a sketch right on that face for you.
ah, right, okay. Oh my god, I should go through it now. Okay,
No
so
worries.
say if I want to sketch this bit, but then this is in the way, how do I hide it?
Aha, wonderful. You see in your sketch toolbox on the right there, so the bit that's kind of like popped up, there's a checkbox called Slice. If you check that Slice button, then it kind of slices the design, hides everything above it, just like that.
Ah, right, okay. This is brilliant.
Awesome.
Thank you so much. I think this is my question for now, but
Cool.
I have more. I don't know, like, because we need to submit this thing tomorrow, so
Yes.
I don't know if you're available to ask questions later or.
Yeah, I think I should be around. If you put them on the Discord, I'll try and keep an eye on that. I have a meeting from 7 to 8, so I might be occupied around then, but I should be generally decently available. So yeah, if you put questions in the Discord, I should be able to help out.
Okay, that's brilliant. I'll do that. Thank you so much for the session.
No worries, happy to help.
Alright, take care. Bye.
You too, see you. Well, that's a bit exciting for anyone watching the recording. Extra content!